right, this is the second free response problem from review day 7, and it gives us a table of values of velocity. First thing they want to know is what's the approximate acceleration at 36 seconds. So that's happening right here. Hopefully you're familiar with that. We're just going to find the average rate of change before and after it. So that's going to be that's going to be 7 minus -4 over 40 minus 32, which gives us 11 over 8. Okay, does ask for the computations. We have that right there, and we want the units of measure. So these are in meters per second. This is the rate of change. This is acceleration. This should be meters per second squared. So they gave us a point for the 11/8, and as long as we have the units right here and on part B, we'll get a point for that. So we'll save that point for just a second. Part B says, using correct units, what does the integral from 20 to 40 velocity equal? So we'll do that here. The integral from 20 to 40 v of t dt is the change in position from t equal 20 to t equal 40 in terms of meters. Okay, so we got the units, meters per second squared, and meters here. That would give us a point for sure. That explanation would give us a point for sure. And then they wanted us to use a trapezoid sum to approximate this. So for the trapezoid sum, there's quite a few sub-intervals, but we're only going from 20 to 40, so that kind of helps out. So for the trapezoid, what we do is we add the things together, multiply by the distance between, divide by 2. So our approximation will be -10 plus -8 times 5 divided by 2 plus -8 plus -4 times 7 divided by 2 plus -4 plus 7 times 8 divided by 2. Now it's weird that it goes from negative to positive. If you graph that, it doesn't necessarily look like a trapezoid, but this does hold for that right there. So this will be -18 divided by 2 is -9 times 5 is -45. This is -12 divided by 2 is -6 plus or times 7 is -42. And 8 divided by 2 is 4 times 3 will give us 12. So if we do this all together, we should get -75 meters. This trapezoid sum was worth 2, so I'm thinking 1 if you show that you're doing it correctly, and 1 if you have the right answer. All right. Part C says, must the particle change direction in any of the subintervals indicated by the data? If so, identify which and why. So we know that if the particle has positive velocity, it's moving to the right or in a positive direction. If it has a negative velocity, it's moving to the left. So there are 2 times where this does change. So we would say 2 times the particle changes direction. All right. Because the velocity switches sign twice. All right, once for the interval, and it would be right here from 8 to 20. So once for 8, 20, and again at, and this time 32 to 40. All right, and what they did was they gave 1 point for those intervals and then 1 point for the right explanation of why. All right, then our last question says, suppose that the acceleration of the particle is positive from 0 to 8. So that means our velocity is always increasing. It starts at 3, it always increases up to 5. It never goes above 5, way above 5, doesn't go below 3. Why then is the position of the particle at 8 seconds must be greater than 30? Okay, so one way to argue this is the minimum value from 0 to 8 would be 3. The acceleration is positive, that means the velocity is always increasing, so our lowest value would be 3. So let's just assume that it was 3. So we know that if velocity was 3, that the integral from 0 to 8 of your velocity, all right, would, if this was 3, then for 8 seconds you'd be going at a constant rate of 3. So we know that 24 would be the lowest value it possibly could be. So this this accumulation of the velocity, this change in position, has to be greater than or equal to 24. All right, and our original position we're told was 7. So the position, we'll say the position at 8 seconds has to be greater than or equal to 7, the initial position, plus the change in position. Actually, we'll say this is equal here. So the position at 8 is 7 plus this change in position, which will be greater than or equal to 7 plus 24, which is 31. So the position has to be bigger than 30 because the change in position has to be bigger than 24, which added on to 7 makes it bigger than 30. So a little confusing there, but they gave 2 points, 1 point for this argument, 1 point for connecting it to there.